we're going to be evaluating functions again, but this time learning another method for doing it. So we're going to start off, and that method is called synthetic substitution. Synthetic. The word synthetic means fake, basically. So it's kind of like a fake substitution. You're not really substituting. It's just another way that gets you the same answer. Okay, and we're going to use that process later on in other lessons as well, when we get into dividing polynomials and stuff like that. But this process is going to be called synthetic substitution again. And before we get into it, I just want to recall what we've been doing basically the last 2-3 lessons is evaluating expressions or evaluating functions. So you see here on your screen, you got the p of x. Okay, so you have this right here, p of x, and that equals 2x squared plus 3x minus 10. You don't have to circle that on your paper. You want to find p when x equals 5. So what do? Well, p of 5. Plug it in, blah, blah, add, subtract, and you get p of 5 equals 55. So you know how to do that. We've done that. If here is this polynomial here, and it's just another example of where when you have x equals 2, substituting in, what do you get, like we did in lesson 2. So here is a q of x function, and what do you do when x equals 2? Well, again, you plug in 2, plug in 2, plug in 2, and notice how the bigger the polynomial gets, the longer it's going to take. So you got to, 2 to the third. First you'd have to do 2 to the third times 3, 2 squared times 10, 5 times 2, minus 4, and then you have to add them all up. Okay, and then you get a final answer of 50. So the value of q of x is 50 when x equals 2. That means we're looking at the point 2, 50. We've talked about that. There's another method to use. There's another way to get this value of 50, and it's called synthetic substitution. That's what I'm going to be showing you in this lesson here. To use synthetic substitution to this exact same polynomial, so I'm keeping it q of x, same function. What you do is, and here's the process, I'm going to go through it with you. You're going to pull out just the coefficients, 3, 10, -5, -4. See those? The coefficients are the constant, the number that's in front of the term, like whatever's in front of x to the third, whatever's in front of x squared, whatever's in front of x, and then just the constant. Those are coefficients, 3, 10, -5, -4. Now we'll leave a space under those coefficients and draw a line. So you have it right here. This is all done for you on your paper. There's really nothing for you to write. You're just paying close attention, and I'm pointing out where I'm at. So we have 3, 10, -5, -4 all set up here, and we leave this blank space here. You might be like, why are we doing this? You're going to see. Okay? You make a little box here, and you put the 2 in the box. The 2 is the number that's going to get substituted in. So you're totally disregarding the variable. All the x to the third, x squared. If you have x to the 7th, it doesn't matter. You're going to totally disregard the x's. You're just going to have a spot for each one. You're going to take the coefficient and write them out like that. Okay, and make sure that whatever number you're substituting in, like the 2 in this case, is in the box. Okay, now here's the process. I'm going to go through this with you. See all the arrows? It's kind of confusing, but you'll see why I put the arrows there once we go through it. You start off with the first coefficient, so that's 3. That just carries down. All right? So 3 is 3. You multiply by the whatever number's in the box, and that's what you keep doing as you go along. So you take that 3 and you multiply it by 2. 3 times 2 is 6. That product goes here. 6. And you add down. 10 plus 6 is 16. Okay? Take the 16. Multiply by 2. 32. That goes here. Add down. See the arrow going down? You add down, and that gives you 27. Take the 27, multiply by 2. 54. Add down. 54 and negative 4 is 50. That last number is the answer you get if you substitute in to 3x to the third plus 10x squared. Remember our original function, minus 5x minus 4. That was our original function. And we just took the number off each one, the coefficient off each one, did this synthetic substitution. That's what this process is called here. And whatever you get at the end of that synthetic substitution process is the value of this number being plugged in for x. Basically, we did it without doing it. We did it in a fake way, essentially. Oh, there's nothing plugged in here, sorry. Okay, so it is the same answer as we got before. Remember, q of 2 equaled 50. I'm going to do another one with you here. Totally different function. See how it works. So 2x to the fourth minus x to the third plus 5x plus 3 when x equals 3. All right, so we put that 3 in the box. 2, negative 1, 5 and 3. Now, in this case, we don't have an x squared term. Now, we did this when we were adding and subtracting polynomials. You want to make sure you have that placeholder. You have to have every single term represented. So there is a 0x squared here, even though it's not written, and that's why I was kind of getting you to write it when we did lesson 2. But yes, there is a 0x squared term. So it's 2, negative 1, 0, 5, 3. Synthetic. Carry down the 2. Start there. Multiply by 3. You get 6. Again, if I'm going too fast, pause it and rewind it. You might have missed something. Add down. 5. 5 times 3. 15. Add down. 15. 15 times 3. 45. Add down. You get 50. And 50 times 3 is 150. And then add down. And you get 153. Now, that means that g of 3 must be 153. So the old way, you would take that 3, you would plug it in, plug it in, plug it in, plug it in, as many times as however many x terms you have. Instead of doing that, you do this synthetic. You just take those coefficients, do the synthetic division or the synthetic substitution, your last number, whatever you end up with at the end there, that is your value of the function, evaluated at g of 3 in this case. All right, same expression when x equals negative 2. So I need to, it's 2, negative 1, 0, 5, 3. 2, negative 1, 0, 5, 3. This time x is negative 2. Bring down the 2. Multiply negative 4. I'm going to start going a little faster now. Negative 5. 10. See, once you get the hang of this, I think you're going to like it. It's pretty easy. Add down. Multiply. Add down. Okay? And that is the value at negative 2. You get 33. So we now know that g of negative 2 is 33. Based on this evaluation, they're going to ask you a question sometimes. Based on this evaluation, what ordered pair will the graph of the function g of x pass through? So what does this mean? Well, think about what we talked about when we did functions. The x is the input, the y is the output, the value of the function is the output, so we have x is negative 2. Well, if x is negative 2, I need the corresponding y value. I know that x is negative 2 because that was given. The y value of the point there on the graph is the output of the function. In this case, it is 33. So negative 2, comma 33, xy is the point that hits the function, on the function, that the function passes through. I'm sorry. Oops. We got one more. All right, so here we have all the numbers represented. Okay, so we got x to the fourth, x to the third, x squared, x, and 12. So we're going to go 2, and then there's a 1 here, so 1, negative 11, negative 4, and 12. M of 2 we're doing. Oh, this box should have been up a little higher. Close enough. Or I guess I just need to move this stuff down a little bit. I'll do that. Okay. All right, bring down my 2. Oh, this should have been, yeah, 2. Okay, so it's 2. 2 times 2 is 4. 5. 5 times 2 is 10. Negative 1. Negative 2. Add down, negative 6. Negative 12. 0. 0. M of 2 equals 0. That would be the value of M of 2. It is 0. Observations. What I'm trying to get out of here is two things. Okay, first of all, you've seen this before where the function equals 0. Think back, or maybe go back and look in your notes and think about what that means. And that's something you're going to need for your warm-up tomorrow. Well, I'll kind of give it to you here. Whenever you see a 0 when the function equals 0, that means that the y value is 0. So if you're on a graph, think about a graph. Where is y 0? Well, everyone says, oh, right here. Well, yeah, everything's 0 there, x and y. Where else is y 0? Well, y is 0 here. Y is 0 here, here, here. See? Y is 0 in a lot of places, all along this line right here. What's this line called? The x-axis. Okay? So basically, whenever you get a 0 for the function, that means that this number here is an x-intercept. So an observation you can make is that 2 is an x-intercept. An x-intercept of the function. We'll just call it m of x. Another observation you can make is that, we'll talk about this more in class tomorrow, is that 2 is a solution to the equation I'm going to write it down here. If you don't have room, just squeeze it in the best you can. It'll be a solution to the equation 2x to the fourth plus x to the third minus 11x squared minus 4x plus 12 equals 0. Okay, because basically m of x is 0 when we found the x value for that. When x is 2, that's when the m of x is going to be 0. Okay, so 2 must be a solution to this equation when the equation equals 0. That's when they say the equation equals 0, the function equals 0. The function equals 0 when the y equals 0, because the y is the function. That's kind of, think of it like that. All right, so that's something that I kind of went through quick there. We're going to do it more in the warm-up. Like during the warm-up, you're going to be doing one of these synthetics, and then you're going to answer a question here, so that'll kind of help you with that. Don't do it now, please. You might be like, oh, I'm going to do it now because I get to do it. Don't do it now. There's something to be said about going away from it. Oh, I get it now. Okay, great. Now let's see what you remember tomorrow. You might be like, oh, I forget it then. That's fine. That's okay. I want you to. I want you to forget it and then go back and look it up a little bit and struggle through it a little bit. That's how you learn. Okay, doing it right now, yeah, of course you can do it right now. I just did it. You can go back and rewind the video. I know you can do it right now. I want you to be able to do it tomorrow in class. And again, that's when you're going to be learning. This is just the information you're going to need to do the work tomorrow to help you learn this content. It was nice to be with you this evening, and I'll see you tomorrow in class.